So, cyclic functions, sine and cos, modeling real life. So we got the temperature in Spain. So the first part of the question, what is the temperature at midnight? So if you read the question carefully, it says T is the time in hours after midnight. So when is midnight? T equals 0. You would need to communicate clearly with words. So midnight is T equals 0. So T equals 22 minus 4. What's sine 0?
It is, I don't know, 0.
So we look at the angle, which is 0, and the y value on the unit circle is 0. Okay, so that's going to be 0. So we have T equals 22 minus 0. Yes, that's, I did it to just make you want to go to Spain right now. That's why I did it. So each of these questions should have a sentence answer. So you don't put Fahrenheit, Celsius, because it doesn't tell you when it occurred. So any ideas? How can we find when the minimum temperature occurred? Okay, graphing's difficult and I want to avoid that. There's an easier way. So if we're looking at minimum and maximums, we are just looking at this part of the function. So we're not looking at the, what's that called? The vertical shift, and we're not looking at the amplitude, okay? So this part, so this is part B, sine, what was it, pi over 12, t equals something. We want this to be the lowest, right? So you want 22 minus this at the maximum. We have the unit circle. When is the maximum sign in the unit circle? Not the angle.
1. Wait.
1. There we go. So we want to make this equal to 1. So we're minusing away the maximum. So it's going to be the lowest temperature. 22 minus the max when this equals 1. Okay? So when does sine of an angle equal 1? What angle now? Pi over 2. So we want to make this thing equal to what? Pi over 2, because then we're going to get the maximum, which is 1. So now we rearrange for t. We get rid of the pi's. 12 divided by 2 is 6. So the minimum is 6 hours after midnight. So if we sub 6 into the equation, we're going to get 22 minus, actually, you need to communicate, so sub t equals 6, or you can write it like this. Have you seen this type of notation? T with the thing you're subbing in. So what's the minimum temperature in Spain this time of the year? 22 minus 4, 18 degrees. So there you go. Wouldn't that be nice to be on a beach right now with a minimum of 18 degrees? Calculate the interval that the temperature varied during the day. So we're now finding the variation of the temperature. So we found the minimum, we also need the maximum. So now we're minusing the least amount. What's the least amount in the sine on the unit circle? Maximum was 1, so minimum is -1. So we want this. We want this equal to, what did I say? -1. So you guys should know what's that angle? -1. 3 pi on 2, or 270 degrees. We're doing pi because the function has pi in it. That's why we're doing it in radians. Does that make sense to everyone? Why did the pi's?
What did the pies say?
So,
Sorry.
what's that in hours after midnight? 18 hours after midnight is the maximum. Oh, you probably should communicate what you're doing as well. So maximum when sine equals -1, rearrange t equals 18 hours after midnight, which is what in real time? 6 p.m. or 1800 if you're in the army. So we have the minimum, maximum. Now we can use this to find the maximum. Temperature equals 22 minus -4. So now we do the maximum, take the minimum. 26 minus, wow. So there's an 8-degree interval. Oh, I forgot to write a sentence. Oh my goodness. Minimum, for the last one you should have written a sentence. Minimum at 6 a.m. The interval during the day. Okay, so C, if you understand B, pretty straightforward.
I'm starting to understand.
D, now we've got some sketching, which everyone loves. Yes, before. It's like skip some numbers. The question, state the period. So let's do that first. How do we find the period? Anyone remember the formula?
2 pi.
And B is absolute.
Yep, 2 pi over the absolute of B. B is the number in front of the t. Do you remember that? If not, there you go, I have reminded you. So the number in front of t is that. So it repeats every 24 hours.
No way.
Look at that. So now you can do your own functions for time around the world. 24. So, like I said, it goes down to the minimum after 6 hours. Any guesses what happens after 6 hours? Back to the equilibrium. After 6 hours, it goes up to the maximum, which is 4 plus 22, 26, which we calculated, and then back to the equilibrium. So see how it's gone through a full phase? There you go, Spain's temperature fluctuation, modelled by a trig function. Don't forget to label. So this is T, and this is T. Minus 4 sine pi over 12t. Okay? Now we come to the really difficult one. This is, the last one is probably a complex type question. So algebraically, big T is greater, or little k is less than big T. That's what we're trying to find. You know, around here, I guess. Let's say that. How can we find the exact time? Exact place. Any ideas? When is the lowest point? 6. So then we could plus or minus what to that 6 to find the answer? We find the average of 3.6. And then you plus or minus that to both sides of 6. 6 by 2. So 1.8. So then we plus or minus 1.8 to 6, and that's when it's that temperature. So 6 plus or minus 1.8. So it's going to be 4.2 to 7.8. Does that make sense? So you could sub in 4.2 into the equation, or you could sub in 7.8. So we know the lowest temperature is at 6 hours, right? It wants us to find the total time that it was this below K temperature.
Okay, and because that K temperature, below the K temperature will always include the lowest temperature, correct?
Yeah. Yep. If it's below K, it has to have a minimum temperature.
Or either K is not on the graph.
Or the K, yeah, the K is not on the graph. So then we just go divide the total amount of time, 3.6, by 2, and then it's plus or minus. Yeah. Oh, actually, I probably should find what K is. So using my calculator, I got 18.4 degrees. So the K value is approximately equals. So I went to 1 decimal because that's what it asked me to do.